In this video, we'll be going over 5 questions in increasing difficulty involving permutations and combinations. Now, before we go over any of these questions, please just let's recall a few things. We're going to need 2 formulas for these questions. First of all, the permutation formula and the combination formula. Alright, so the permutation formula is equal to n factorial over n minus r factorial. That's a horrible exclamation mark. That is the permutation formula, and the combination formula is just that, but divided by r factorial, which is going to be n factorial all over n minus r factorial times r factorial. Those are the two formulas you're going to need for these 5 questions. And also note that before I take over any of these questions, please just try them yourself first, and then you can just check over your answer. So here's the first question. It states a club has 10 members. In how many ways can you choose a committee of 3 members? So first, we need to decide, does order matter? Well, does order matter? Okay, so let's think about this. A club has 10 members. So we can think those 10 people here. I'll just represent them as these little circles here. Say we call them like person A, B, C, D, and so on. And let's say inside this box is the committee. Let's say we choose people A, B, C in order A, B, C, and then in some other case we chose C, B, A. We notice that in this case, in this context, that these two are actually the same thing. That would mean that order does not matter here. And so we're doing this because we first need to decide, is it a permutation? Is it a permutation question, or is it a combination question? And in this case, order does not matter, so it's going to be a combination question. Okay, so knowing that, we can simply just use the combination formula. In this case, n would be 10 because that is the total number of objects we are choosing from, and r would be 3 because we are choosing, out of the 10, we're only choosing 3 of them. So it will be 10 choose 3, which is equal to 10 factorial all over 10 minus 3 factorial times 3 factorial. That's the same thing as 10 times 9 times 8 times 7 times 2 times 1 all over 7 factorial, which is just 7 times 6 times so on 2 times 1 times 3 factorial. We notice that we can actually just cancel out the 2 7 factorials, and then we are left with 10 times 9 times 8, which is 10 times 9, 90 times 8 is 720, all over 3 factorial, which is 6. And just simply doing the division, we get 120. And that would be your solution. So this basically means that if the club has 10 members and you want to choose a committee of 3 members, there's 120 different ways to do that. And that would be the full solution for this question. So here is the second problem. Okay, 5 people are to be seated in a row. 2 particular friends, Alice and Bob, must sit next to each other. How many arrangements are possible? Okay, so just like the last question, let's first try to decide, does order matter or not? So we can actually, okay, so in this case, we'll represent the 5 people as A, B, C, D, and E, and we know there's 5 spots, because it said that 5 people are being seated in a row. So all 5 are included. If we have A, C, B, D, E, that is actually different from A, B, C, D, E. So yes, order does matter in this question, which means that it is a permutation question. But it's still a little different. There's a restriction. It said that 2 particular friends, Alice and Bob, must sit next to each other. So here, just for the ease, we'll call A Alice. So this is Alice. And we'll call B Bob. Is the name Bob? Yep. Okay, yeah. So A and B is Bob. And this is actually a really clever way to solve this. So here, I'll write this again right here. A, B, C, D, and E. And there's 5 spots. We can actually treat this A and B as one element. We'll call it F. If we treat A and B as one element, we can do that because A and B is always together. And if A and B is always together, now this is the same thing as if there's 4 spots. Delete that. Now we have 4 spots, but now our elements are F, C, D, and E. And now the question becomes, how many different arrangements can you form with 4 different objects? So, and we know that that is simply just 4 factorial. 4 factorial arrangements, because at the first spot there's 4 possibilities, and then there's 3 at the second one, and there's 2 at the third, and there's 1 at the last. So we just multiply them together, we get 4 factorial. But that's actually not the answer here. We have to do one more step. So here, I'll write down the 4 factorial right here. But you also note that F can be AB, or it can also be BA. That means that for each of these 4 factorial cases, for our secondary arrangement right here, whoops. So for these arrangements, for the 4 factorial ways, for every single one of them, there's an alternative, and that's going to be this right here, BA. So for each of the 4 factorial ways, if there's another arrangement, then we can simply just multiply the 4 factorial by 2. And 4 factorial is equal to 24, and 24 times 2 is equal to 48. So that would mean that for this question, there are 48 different arrangements are possible, and that would be your final solution. Alright, so here is the third problem. It's asking, how many distinct arrangement of numbers can be made from the letters of the word balloon? Alright, so for this problem, let's just write down the letters of balloon. B, A, L, L, O, O, N. Alright, we already know this is already one arrangement. And now here, the word balloon has 7 letters, and so you might be tempted to, just take these factorial of 7, that'll give you the arrangements. And let me show you why that's wrong. So if I write down 2 different things, well, I say different, but now, do these 2 things look different to you? It's likely that they don't look different to you. They're using the same letters in the same order. But if you were to be taking 7 factorial, you're actually counting this as 2 different arrangements. And the reason for that is because if we call one of the L here L2, actually no, just for a second, I'll call this L1 and we'll call this L2. Your other arrangement could be that this is L2 and this is L1. That's what 7 factorial is counting. They're counting this as 2 different arrangement of L's. But we know that to us, they look the same. So we actually want this to be one arrangement. But 7 factorial is overcounting. And so we need to find out how much is it overcounting by. If I gave you another arrangement, actually here, we'll completely random. We'll just write it backwards. N-O-O-L-L-A-B. Alright? That's another arrangement. Now what if you have N-O-O-L-L-A-B? But let's say the L is in a different order again. L1, L10, and we have 2, 1. It's overcounting again. It's counting a duplicate. Here. It's counting a duplicate for each arrangement that we do want. So, actually, pretty simple enough. We can actually just take the 7 factorial, which is overcounting, and divide it by the number of duplicates. We know that for each arrangement that we do want, there is another one. So we just divide it by 2 to make it 1 again. And then you notice there's also the duplicate O's. Alright? There's also the duplicate O's. And we can actually say the same thing about O's. This could be 1, 2, and this could be 2, 1. And same thing here. This could be 1, 2, this could be 2, 1. And similarly to L, O is also getting another duplicate for each arrangement that we do want. So we actually just divide it by 2 again. Otherwise here we can just multiply the denominator by 2. And at this point, we just use a calculator to compute the value, and we get 1,260 different arrangements, and that will be your full solution. Okay, so this is the fourth problem. Okay, so let's go over this. This one's a little bit trickier, but the problem states a bag contains 5 red marbles, 4 blue marbles, and 3 green marbles. If 4 marbles are drawn at random without replacement, what is the probability that exactly 2 red marbles, 1 blue marble, and 1 green marble are drawn? Okay, so looking at this, it's a probability question. What is probability? Let's say probability percentage. What is that? Well, that is just equal to the number of favorable outcomes divided by the number of total outcomes. Whoops. Outcomes multiplied by 100%. That's what probability is. And so let's try to visualize this question. So there's a bag. So I'll say this is the bag. And we have five red marbles. Actually, I'll just do that as letters here. 5 red, and we have 4 blue, and 3 green. Okay, so if 4 marbles are drawn at random, so we know out of this bag of 12 marbles, we're drawing out 4. So actually, it's pretty easy to find out the number of total outcomes. So now let's decide, does the order matter or not? Well, in this case, order does not matter. We could be picking, say, blue first, and then red, and then green. That is the same thing as if you picked green first, and then red, and then blue. Here, red, and then blue. They're the same thing. Order does not matter, therefore we can just use the combination formula. So the number of total outcomes is simply just going to be the total number of objects, which is 12. Choose the number of objects we're picking, which is 4. 12 choose 4 is equal to 12 factorial over 12 minus 4 factorial times 4 factorial, which is just 12 factorial over 8 factorial, 4 factorial. And we can actually just do this 12 times 11 times 10 times 9 times 8 times so on 2 times 1. And so we know that we have our 8 factorial, and then 4 times 3 times 2 times 1. The 8 factorial just cancel out with this bit right here. We're left with 10 times 11 times 10 times 9 all divided by 4 times 3 times 2 times 1, which is just 495. Alright, so that is our total number of outcomes. And now we want to know what is the number of favorable outcomes. So what do we want? We want exactly 2 red marbles, 1 blue marble, and 1 green marble. So let's try to do that here. So we can actually just straight up do it from the probability. Our probability is going to be equal to something over 495. Okay, so let's try to look at this. So how many in our first draw? What are the number of red marbles that we can choose from? So first it's gonna be 5 because there's 5 red marbles, and then if we chose 1 red marble, now we're left with 4, and now we just want 1 blue and 1 green, which is gonna be 4 and 3 because there's 4 blue and 4 green. But we're not done here, because actually our 5 times 4 right here is over counting. This is a permutation. I don't know if you realize, if we could have just used if we use permutation formula for this is what we get. And that is wrong, because in this case order does not matter. So we want to divide this here. So let's take this here. We want to divide this by the number of time it overcounts. So to actually help you visualize, let's say these are all red marbles, okay? A, B, C, D, and E. let's say these are all red. Okay, so we know that we're choosing two of them, and let's say we chose A and B. A, B. Our little 5 times 4 right here is treating as if A and B is different from B and A. But that doesn't matter to us right now because they're all just red. Similarly, like if we chose like C and D, that's a B, C and D, our 5 times 4 is counting as if that is not the same thing as D and C. And you notice that for every arrangement, let's call it like X and Y, there is a duplicate Y and X. So for each one arrangement, there is a duplicate. So there's 2. Therefore, we just divide this number by 2. Otherwise, in our little equation here, we can actually just do 5 times 4 divided by 2 times 4 times 3 all over 495. And if we just do the calculation, then that should give us, so I'll call it P percentage is equal to 8 over 33. Or that is around 24.3% chance. And that will be your full solution. Okay, so here is the fifth or the last question. Yeah, I marked that as challenge because it is the most challenging one on this list today. So, the question states 10 distinct books are to be arranged on a shelf. 2 specific books, book A and book B, must have exactly 2 books placed between them. How many arrangements satisfy this condition? Okay, so let's try to visualize this question. So we basically have 10 books. Actually, I'll just do little lines, underlines. I'm not drawing 10 boxes. 2, 3, that's 7, 8, 9, 10. Okay, just like that. And we have 2 books, book A and book B, but they must have this 2 space. Here, I'll mark out this 2 spots. They must have 2 spots between them. And we just want to see how many arrangements actually satisfy this condition. So we're looking at arrangements, so we know that order does matter. Whoops. Order does matter. Okay, order does matter. And there's actually a less rigorous way to solve it. So at least when I solved this question, it wasn't that rigorous, which actually might be disappointing for a few of you, but trust me, it's a pretty nice solution. So let's say we have A, and then we're gonna have 2 spots, and then we're gonna have B, and then we're gonna have 6 spots left, because there's total 10 spots. Just like that. And then we have another case, which is gonna be B, we're gonna have 2 spots, and we're gonna have A, and we're gonna have 6 spots left. And then we can just shift them over. A, 2 spots left, B, and we have 5 spots left. And we can actually just keep doing that. And then we're gonna have some case where we have A and B like this. And then we're gonna have 3, and then we have A, 2 spots, B, and then how many is that? 1, 2, 3. Wait, 1, 2, 3, 6. Okay, we got 2 spots left here. Actually, we're gonna have 3 spots left here. So just like this, we can just keep going. And we can more easily visualize. We can have an arrangement like this. For this little arrangement right here, it's 2 different arrangements because we can have A and B, and we can have B and A. And then we have arrangement like this, and we have like this, and then we have like this, and we have like this, and then we have like this, and we have like this, so on. And how many do we have? We actually have 8 of those. Wait, no, not 8. No, not 8. I meant 1, 2, 3. Okay, we have 7. We have 7 of those. And you can see it. We have, okay, here, let me do this. 1, 2, 3, 4, 5, 6, and we have 7. Okay, but we know that for each of those, there is a duplicate because we also have AB and then we have BA. 7 times 2. And then we notice that for each of these, every single one of them, A and B, they take up 2 spots, and then how many are we left? We're left with 1, 2, 3, 4, 5, 6, 7, 8 spots for 8 different books. And now the question becomes, how many different arrangements can you make with 8 books on a shelf? Well, we know that's just 8 factorial. Do you understand it? So now, this is actually our final solution. So, 8 factorial is pretty difficult to do it by hand. So I'm just going to use a calculator. And when I use a calculator, I got 564,480 different arrangements. And that is actually our solution. And that'll be the end of this video. So I hope this video helped you understand how to solve general permutations and combinations problems. Maybe it reminded you of what the combination formula is, what the permutation problem is, formula is, and how to use them. And so that'll be it, and I'll see you in the next one.